Assalamu alaikum. Today we will start with chapter 7 about work and power. Before we start, please prepare your stuff and follow these instructions. At the end of this video, you will be able to define the work of a force, recognize its SI unit, establish a relationship between work, distance, and a force, calculate the work done on an object. We already know from the previous chapter that the weight of an object is the force acting on it due to gravity or due to the attraction of Earth. The weight is equal to the mass multiplied by the gravity, and its SI unit is in Newton, referred to as Isaac Newton. Experiment time. Observe the following cases, then answer the questions that follow. We have two cases, case 1 and case 2. Let's start. Number 1. A force is done in both cases. Justify this statement. Why do we have, or why we are saying that the force is done in both cases? Let's remember, a force is a push or pull. If you notice, in both cases we have the action of pushing. For that, the force is done in both cases. Number 2. Referring also to both cases, compare the results. At the end of this experiment, case 1, what happened, and case 2, what happened. In case 1, if you notice, the box moved, while in case 2, the box didn't move. In which case did the point of application of the force change or displace? In which one? Of course, it is in case 1. Why? Because it starts from this point and ends at this point. Knowing that work is done only in case 1, tell when a force is said to do work. We said before that the difference between the two cases is that the point of application had changed. So, a work is done only if the point of application of the force is displaced. What is the definition of a work? A work is said to be done by a force when the point of application of the exerted force is displaced. This is the point of application of the force done on the ball. This point of application changes from here to here, so the work is said to be done by this force, the force of pushing. Please open the booklet on worksheet 8. A boy raises 3 boxes, A, B, and C, to a certain height, as shown in the figures below. Observe these figures, then answer the following questions. We have 3 cases with 2 different conditions. Let's start. Number 1. Indicate the manipulated variable in case A and B. Observe the figure. What is the different thing between case A and case B? That's right. It is the mass of the box. So the manipulated variable in case A and B, it is the mass of the box. Very good. What about in case B and C? What is the difference between the two cases? The difference between the two cases is the distance or the height on which the boy raises the box. So the manipulated variable here, it is the distance or height. Number 2. In case A, a force greater than the 2 other cases is required to raise the box. Justify why. The force depends on the mass. Why? Since the boy should exert a force equal to the weight of the box to raise it. So, the force in case A is higher than that in case B and C, because force equal mass times gravity, and here the gravity is constant since the boy is in the same location. So, the force exerted by the boy on the box raised is more than that in case B and in case C. The mass of the box A is greater than that of the box B and C. As we notice here the mass of the box is 4 kilograms, while in case B and C it is 2 kilograms, which means that the weight of the box A is greater than that of box B and C. Why? Because the weight equal to the mass multiplied with the gravity. So the force required to raise the box in case A is greater than that in case B and C. Number 3. The boy does work when raising each of the boxes. Explain why. We said that the work is said to be done by a force when the point of application of the exerted force is displaced. If we notice here in the figure, the boy raised the box, so the point of application changed from here till here. So the point of application is displaced. For that, we say the work is done by the boy. The amount of work done when raising box A is greater than that done when raising box B. Justify why. Let's see both cases A and B. In case A and B, the distance are equal to 0.5 meter, but the force exerted by case A is greater than that of case B. Why? Because the boy in case A has a mass greater than that in case B. So the boy must exert a higher force to raise the box in case A than in case B. For that, the work done when raising box A is greater than that when raising box B. Number 5. The amount of work done when raising box C is greater than that done when raising box B. Justify why. Let's see case B and C. In both cases, the masses are equal. So that means the forces exerted by the boy on the box in both cases are the same. What about the distance? The distance to which the boy raises the box in case C is higher than that of case B. So the boy needs to do more work to raise the box higher. So for that, the amount of work done when raising box C is greater than that of B. Indicate the factors that determine the amount of the work done. We talked about two factors, which are the distance and the force exerted by the body. Establish the relationship between work and each of the factors mentioned in question 6. Let's return to the cases. Referring to case A and B, we noted that when the force is greater due to greater mass, the boy exerts more work. For that, when the force increases, the work increases. What about the distance? Let's go to case B and C. From cases B and C, we noted that when the distance is greater or higher, we noted that the boy exerted more work to raise the box. So, from this information, we can say when the distance increase, the work increase. Infer the formula that relates work to these factors. Let's take a closer look on the formulas of math. If we have a ratio of C equal A over B, C and A are considered proportional, which means when A increases, C increases, and vice versa. If A decreases, C decreases. And C and B are considered inversely proportional, which means if B increases, C decreases, and vice versa. From this rule, let's get the formula of work. How? We said that when the force increases, the work increases, which means they are both directly proportional to each other. And also we said when distance increases, the work increases. So also we can say that both distance and work are directly proportional to each other. So in other words, work equal force times distance. Using the formula of part A, calculate the amount of work done in each case, starting with case A. Let's start with the formula. Work should be equal to force times distance, but here what is the force? The force needed to lift the box is the weight of the box, which is mass times gravity. For that, work equal force times the distance, or mass times gravity times distance. So mass is equal to 4 kilograms multiplied with gravity, which is 10 Newton per kilogram, multiplied with the distance, which is 0.5 meter. The answer will be equal to 20 joule. Try to solve by yourself case B. Work of B equal also force done by B multiplied by the distance of B. It's also equal to the weight multiplied by distance. Weight is equal to mass multiplied with the gravity. So the equation will be mass multiplied by gravity times distance will be 2 times 10 times 0.5 meters equal to 10 joules. The same for case C. Work equal force times distance equal weight times distance of C equal the mass of C times the gravity multiplied by the distance to which the boy raised the box will be equal to 20 joules. In the SI unit, the joule unit is equivalent to the product of two other units. Write each unit in the convenient blank. To know those two units, let's take a closer look to the formula. Work equal force times distance. The force is in Newton and the distance is in meter, while work is in joule. So joule will be equal to Newton multiplied by meter. Let's take a closer look on this pyramid. From this pyramid, we can calculate any one of these three factors if we have two of them. Work is equal to force times distance. What about force? Force equal work divided by distance, and distance equal work divided by force. Extra exercise, let's apply. A volleyball player throws a ball upward to a distance of 0.5 meter. The mass of the ball is 475 grams. Given that the gravity is equal to 10 Newton per kilogram, calculate the weight of the ball. Weight is equal to mass multiplied with gravity. But note that mass is in grams. We should convert it into kilograms, so we will divide it on 1000. Now we can calculate the weight. Weight will be equal to mass times gravity, so we will multiply the mass with 0.475 multiplied by 10. The answer should be in the SI unit, which is in Newton. The player did a work on the ball. Justify this statement. Why we are saying that the player did a work on the ball? If you notice here, the point of application is displaced. To say that the work is done, the point of application of the force applied on the ball should be displaced. Now we can calculate the work done by the player. Work equal force times distance. The force here is the weight, so we have weight multiplied with the distance. We will obtain 2.375 joules. Let's sum up. Work. A force is said to do work when its point of application is displaced. Work in joule equal force in Newton multiplied with the distance in meter. The SI unit of work is joules. We can calculate any factors of this formula if we have two of them. Please, for next time, study the summary, the extra exercise, and worksheet 8. Thank you.